Let's compute the equation of the tangent line to the graph of that beast up there, where the tangent line happens to pass through this point. And if you check out what happens when x is equal to 3, plug in 3 in for x, the corresponding y value is not 3/4. Do you see my point? So I think I'm completely off with this the way I'm saying it. So let's take a break. I need more room, so let me move to the left.
Yeah.
I do not disagree with my first line. I do think that the equation of tangent line really is indeed just this. This is nothing more than a glamorized version of your point slope formula back in Math D. Y minus y1 equals m times x minus y1. However, it is the case that another name for f of a is I don't remember.
Root a over root a plus 1.
Is equal to f prime of a times x minus a. Where I guess I do need to take one simple break. Pulling out a piece of scratch paper. If f of x is equal to, you guys, can you help me again?
Root x.
Got it. Let me take a quick break. Since I need to evaluate f prime of a, let me just compute the first derivative function. I think the first derivative function can be computed by using the product rule or the quotient rule. So I get what's downstairs as is, times the derivative of what's upstairs,
1 over 2 root x.
minus what's upstairs as is, do not touch, times the derivative downstairs.
1 over 2 root x.
All over downstairs twice. But I think in the end, all that really gives me is, I have no idea what it gives me. Is that just 1 over x? No, 1 over 2.
2 root x. Quantity x plus 1 squared.
Is it 2 root x?
Yeah, it's 1 over 2
Yeah.
x.
Yeah, I agree. I agree. I actually had something different in my head when I looked at it. Oh shoot, that must be another name for f prime of a is just simply 1 over 2 root a times root a plus 1 twice. You guys, if a is a constant, I want a yes or no answer. If a is a constant, is that really an equation of a line?
Equation, no.
See, I think it is. If a is just a constant, x is only being raised to the first power, y is being only raised to the first power, that is the equation of the tangent line to the graph of f at a given value of x equals a.
Oh, I thought you said point slope.
Well, it is in point slope form. Well, I know, but if these are just constants, oh, you're thinking of slope intercept form.
Yeah.
I'm saying, is it in point slope?
Oh, yeah.
It is. Oh, shoot, you know what? This isn't going to work. I'm supposed to find value for a. How do we do that?
Plug in points into the x and y. And
I
solve
agree
for a.
completely. Yes or no answer. Is this a point on the graph of f?
No.
No, it's not. Yes or no answer. Is this a point on the graph of the tangent line?
Yes.
It is. So if I plug 3 in for x in, 3/4 in for y, that should be a true statement. However, when I plug 3 in for x, and correspondingly 3/4 in for y, you guys check this out. Here's a corresponding equation. I get an a. And if I can just sit here and solve that equation for a, I've got the value of x for which I have a point of tangency. Do you guys agree? Okay, that being the case, let's solve for a. And in solving for a, you laugh.
Two liner watch.
And if I were to solve for a, I just get rid of fractions. To get rid of fractions means I multiply both sides by anybody? No, nobody.
I'm just going to watch you do it.
Well, wouldn't I multiply both sides by 4 root a times root a plus 1 squared?
Yes.
You guys be honest, tell me if I'm skipping too much. If I did that, wouldn't that merely give me a 3 root a times a root a plus 1 twice? My second term would give me 2a times root a plus 1 once.
Can you explain that step?
Yeah, here's what I'm really doing. Let me just, in black, I'm not going to change anything. I'm just going to copy what I have. It's 3/4 minus root a over root a plus 1 is equal to my 1 over 2 root a times root a plus 1 twice, times stuff. Now I think the smallest expression up here, into which those 1, 2, 3 denominators divide evenly, is this a 4 root a times the root a plus 1 twice. And that's what I'm going to multiply both sides by. Man, is that a strong pen, jeepers. So what I'm doing in red is merely multiplying both sides by the LCM of those 3 denominators. And if you guys, is that okay for the LCM?
So you multiply 4
Else.
times root a plus 1 times 2 root a plus 1 squared.
I'm nervous about the word so. I really just multiply by the red beast. I heard you say 4 and 2 as well.
Well, no, but to get that, did you multiply the 3 denominators together?
No, didn't do nearly that much work.
How did you get the red?
And sir, if you do what you're doing, it's perfectly legal. I just think with the equation you would generate, there'd be a lot of cancellation left and right. What you're doing is just fine. I'm just efficient. I don't want to simplify as much in the end. So I did this. Somebody help me in black. The first denominator is a 4, isn't it? The second one is a root a plus 1? What's the third one?
2 root a, quantity, root a plus 1 squared.
Gotcha. So you guys, you check this out. If I took the time and just broke everything down to its basic factors, can I think of 4 as this? Oh, the second one I can't do much with. It's just a root a plus 1. But the third one I can think of this times times itself twice. You guys remember back in algebra, if you were to find the least common multiple of these 3 beasts, you'd say this. Yes or no? Do you see a 2 anywhere up there in one of those 3 factorizations?
No.
Yeah, you do. How many times?
Twice.
Twice. 0 times.
Once.
Once. But if I'm going to build the smallest expression up here into which those 3 expressions divide evenly, since one of them involves a factor 2 twice, which is the greatest number of times you see as a factor in any one of those expansions, I know the LCM has to have that factor twice as well. The LCM has to have any factor you see anywhere, the greatest number of times you see it in any one of these 3 expansions. Humor me. Do you see a root a somewhere as a factor?
Yes.
How many times?
None.
0 times.
0.
0 times.
Once.
Once, but the greatest number of times you see that occurring as a factor is 1, so it shows up in my LCM once because these 3 beasts have to divide evenly into it. The one that involves it once has got to divide in as well, so that thing up there better have a factor of a. Better have a factor of root a, I said a. So humor me. How many times do you see root a plus 1 as a factor? None. 0 times. Once. Twice. So the LCM should better have it twice. Therefore, I got a factor of root a plus 1 quantity squared. And that is exactly what I wrote in red. Well, I wrote it as a 4 instead of a 2, but you see where I got it? Okay, if you do, then number 2, what I'm doing in red is perfectly legal. I'm merely multiplying both sides of my equation by the same darn red beast. That's always legal. It's called the multiplication property for equality. I do think, however, taking my red action is really useful. Because number 1, when I distribute the red beast over the subtraction in black on the left-hand side of the equal sign, with the first term, the 4's canceled, I'm simply left with that garbage. And when I multiply the second black term by this stuff, one of the root a plus 1's cancel. I'm left with 1 root a plus 1. Oh, and a 4. Oh, and a root a. And another root a, which is a. And that's exactly where the second term came from. Oh, you guys, life's even easier on the right-hand side. So number 2, on the right-hand side, check out how this black denominator cancels completely with that red factor. I missed it, didn't I? It doesn't completely factor to the remaining factor of 2 upstairs. I didn't even see it. So I guess in the end, on the right-hand side, I'm left with a 2 times. I can't read that far. Is that a 3 minus a? You guys have to at least appreciate the fact that at least I got rid of all the radical. Oh, excuse me, I misspoke. You have to appreciate the fact that I got rid of all the fractions within the equation. So, next, I will remove parentheses as best as I can. Oh, shoot, maybe I can't over here yet. Expanding the binomial squared. What do you think?
A. Plus 2 root A, plus 1.
minus
2A,
2A root A.
root A, yeah,
minus
2A.
is equal to a 6 minus 2a. And if I continue to remove parentheses, I'm left with a 3a root a plus 6a plus 3 root a minus 2a root a minus 2a. Is that equals 6 minus 2a? Let me combine like terms on the left hand. Like, for example, how about this beast with that beast? They combine into a single a root a. Next, I guess I can combine this triply underlined term with this triply underlined term. That gives me a positive 4a. And lastly, I got a remaining factor of positive 3 root a, and I've got some stuff on the right-hand side of the equal sign.
4-liner.
If I bring everything to the left-hand side by number 1 adding 2a, number 2 subtracting 6 from both sides, that gives me an a root a plus is that a 6a? Plus 3 root a minus 6. Yes or no answer? Is that a polynomial equation?
Yes.
Yes or no answer? Is that a polynomial equation?
Oh, you have to factor. So. No.
We know one.
Well, you have to,
Why isn't it a polynomial?
oh no.
Yes, you do. You're right.
You have to move some of the terms around, I think.
More than that.
It's not exponent?
I see lots of exponents. What do you say about the exponents?
They're
Well, there's
wrong.
one half, and then
They're fractional exponents. Beautiful. So I think if you guys don't mind, we can get rid of them. Do you mind if I just quickly make a substitution? Not that you guys have to write this step, you don't. But to show you that this can be transformed in a piece of cake, easy polynomial equation, let's just come in and replace the root a with, I don't know, I'm making up a letter out there. How about b? And if I do, I have left over nothing more than a b cubed. Is that a plus 6b squared? Is that a positive 3b minus 6 being set equal to 0? I think that is nothing more than a polynomial equation. How are you going to solve it?
Combine like terms.
They're already combined. Be careful. That's a b, and that's a 6.
What about BB squared?
No, that's a 6b squared. I should not use the letter b, I'm sorry.
Should have picked something.
So you would get 7B
Yes, I
squared.
should.
Why did you pick a B?
Well, it'll be
Leave me alone. It was next to the letter a in the alphabet.
It'll be 7B squared, no?
Oh, did I make a mistake?
Well, B squared plus 6B squared?
Yeah, that's B cubed.
Oh, it's B cubed?
Yeah.
So bad.
We'll finish this problem before the night's over. Are you okay with that?
Yes.
And if you are, how the heck do you solve such a polynomial equation?
Synthetic division.
When you say the division, I don't know what to put in the box.
Huh? You don't know what to put in the box?
Yeah, that's why you start looking for P's and Q's. And
Where
then
P's
did
and
you get
Q's.
from?
rational root.
The rational root there. That's where it came from. I agree. So if this polynomial expression right here has a rational 0, it's going to be of the form P over Q. Where P divides evenly into the constant term, and Q divides evenly into the leading coefficient. So I guess my choices for P and Q, well, at least for P I should say, are going to be plus or minus plus or minus plus or minus plus or minus. Oh shoot, was that nice to you? I guess the Q is going to be plus or minus period. So let's give some a shot. Let me pull out a piece of scratch paper.
So in a different way on
If I
this.
list my coefficients,
That's fine.
So we got
please
the
give
right
me a
answer.
hand. Let's save some time on the clock. What works that
Huh?
idea?
We tested it.
Yeah. Gotta be right.
Well, we'll go with
One
Let's go
definitely is not.
with 1.
negative 1.
Negative
Negative
1.
1. Let's see if it works. 1 times negative 1 is
Negative 1.
a mistake. You start the process by doing what? Dropping it. Yeah, you drop it like a rock. And then you
Negative 1.
and then if you subtract, you
You add.
get a mistake.
You add.
Hold on. So, unlike polynomial long division, we don't subtract, we add. Then we multiply. Then we add.
2.
Holy cow, negative 1 times 5 is, yikes, sorry. That was me, not you. If I add, I get,
Negative 2.
and I multiply, I get,
2.
and I get.
Negative 4.
Yeah, it's not actually a 0, is it?
No.
So what else can I try? What definitely does not work? You want to try 2? Well, if I try a 2, that generates for me a 1, a 2, an 8, 16. How about something else?
Negative 2.
If I try a negative 2, it's going to give me this.
Too big.
Nope.
Small. Too big.
Not gonna work.
It's not giving me 0. What else works? Didn't even do this. I didn't do it myself.
Negative 3.
Negative 3.
Well, A
Yeah.
equals 1.
We did it a bit differently.
A equals positive 1.
Yeah. And it turns out to be,
Well, A
Times
will
1.
equal 1 down the line. That it worked.
well, it factors out A equals 1, 3 plus or minus
See
is
how valid
3
that is.
root 33.
No,
over
I
2.
actually, Randall, I'm
No,
confused.
we
Say
had-
one
we had
works, but I
Chuck
made a
look
mistake,
at
'cause I
it
can
and
tell right
everything,
away
I
when
mean-
this definitely does not work. Is everything okay with my algebra? Can I check it real quick?
Yeah.
Did we differentiate correctly?
Yes, that's correct.
Okay, I just double checked that. That looks good. What about over here?
Because we took the long way on that. And
So, cancellation, root A times this, times 3, got it. Minus 4A times, oh, shoot.
I think we factored out the root A
No, you
plus
guys
1,
look,
did
this is
we?
my mistake.
Oh no,
Two.
there we yeah.
Look, watch. If I multiply this red B second black fraction, I think one of these binomials cancels. I think root A times root A is A, but there's a factor of 4, not a factor of 2. Do you see it? So that's my mistake, not yours. Can I go fix it real quick? Since I think, I'll put this in red so you can see where my mistake is. Since I think this really should be a 4, you guys give me a second, I'll make the changes. I guess that changes these two coefficients to be 4. That changes these two to be a 4. But then I collect some like terms, and I think above squiggly line, that's going to give me a negative, one of these. As far as the A's are concerned, I think that's going to give me a positive 2 of the A's, not a 4 of them. So I still have a negative sign out front here. But in adding 2A to both sides, I think it's going to give me a total of 4 of them. You guys, so far, is that okay?
Mhm.
My sincere apologies. I really did commit that arithmetic blunder. So let me fix it. Multiplying both sides by -1, still making the substitution. Does that give me this? Does that give me a b cubed? Is that a minus 4b squared? Is that a minus 3b? Is that a positive 6? So I guess my choices for p and q don't change. But you guys, here's my shortcut. You know, the positive one really works as a rational 0 for that polynomial expression. What that really means at the end is that when you add the coefficients, you get 0. So question, when I dive in and add those coefficients, do I really get 0? Yeah, I do. So I know positive one's going to work. Can I give it a shot with synthetic division? Just to prove it to you. Well, since I blundered my coefficients, I guess that gives me a 1, -4, -3, and 6. Let's try it. Drop, multiply, add, multiply, add, multiply, and add. Thank goodness now that I found my numerical coefficient error, it really is the case that one of these rational numbers is a 0 from the polynomial expression. What the heck does that really mean? I think it means a lot. Because I think that means that this four-term polynomial expression can be rewritten as b minus 1 times whatever the heck the quotient is upon polynomial division, which will give me b squared minus 3b minus 6. Oh shoot, you guys, I can't factor the second trinomial, but it doesn't matter. I think in the end, using the principle of zero product, since the product of these two b's is equal to 0, then either the first one's equal to 0, or the second one is equal to 0. And if I can't factor this trinomial, all I'm going to do is apply the quadratic formula, which tells me that my solutions are going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Or shall I say b is equal to my 3 plus or minus yeah, I can't do anything, it's just a root 33, I'm stuck with it. All over 2. And if you can't remember the quadratic formula, who the heck cares? You're simply gonna
Put it in
I
the
say-
calculator.
no. If you can't remember the quadratic formula, you're gonna
Memorize it?
no, guys. How'd you get back
Oh, dude,
My batteries are dead. I can't look up anything.
You could just do your P's and Q's again.
It wouldn't work because these are not rational numbers.
give up.
No, we're not French. I take that back. I'm half French. I can say that. Anybody? Yeah, thank you. Because I did the quadratic form as nothing more than a generalization of the complete square method. You guys there? All right. Shoot. What have I just done? I've lost track. I found the equation of the tangent line.
No, you found
No. I found
B. B's.
You found
what
A.
about them?
equals root A.
You have to make them A's.
What root A equals?
You have to
Find
square
the
it.
zero of A.
You're gonna have to square it.
Okay, so number one, I really haven't dealt with the issue of what the heck those values for A are. So I think I need to come back in and substitute. Recall that I had another name for B, namely root A. So let me write these two equations, replacing B with root A. Which means, of course, A is equal to, is that plus or minus 1?
One.
No, it's just positive 1, because I'm squaring both sides, I'm not taking the square root of both sides.
Wait.
And over here, I have that A is equal to 3 plus or minus root 33.
Okay.
All over 2. Well,
Square.
I've got 3 choices for A. Do they all work?
No,
No. Actually, I have no idea if they do or not.
They don't.
I do.
So, what have I just I gotta close my pen. Seriously, what have I just accomplished?
You found A.
Found possible values for A, which are the points of tangency, or at least the values of x of the points of tangency, for which a tangent line passed through the point 3, 3/4. It is tangent to my curve at a value of x that I'm labeling A, and there's 3 choices. So, I need you guys to be honest. I'm sorry if I made the silly arithmetic error in the middle board, but I need some room. Is that okay? Because if not, I'll talk about it. But if it is okay, I need to erase it so I can get some room.
That's good.
All right. If it is okay, then I think for the equations of the tangent lines, I'm going to go ahead and talk about the equation in the form y minus f of a being equal to f prime of a times x minus a if x is equal to, I've lost it, was it positive 1?
Yes.
Well, sorry, I meant to say a is equal to positive 1. Same thing. A is just a choice for value for x. Let's plug it in. Well, plugging 1 in for a, I think what I'm going to get over here in this equation is that a 1 over
1/2.
2? And I think for the f prime of a, that's going to give me a,
1/8.
yes, I agree, it's 1 over 2 times 2 squared times x minus a. Or shall I say, y is equal to 1/8 x minus 1/8 plus 4/8, which is positive 3/8. What do you guys think? So that's one equation of tangent line. There's one
Well,
answer.
you need to check it out first and make sure that it all adds up. You're plugging in X and Y.
If you insist. I definitely wouldn't bother, but if you insist.
Well, one of them it doesn't work, so.
Well, it definitely works for this one because,
Yeah.
technically speaking, that was one of the factors of this particular Pony
Yeah.
expression. I think the issue comes into play with this particular equation. Because technically speaking, you guys, what I've really done was I solved for root A and I squared both sides. If you square both sides, you might generate an extraneous solution. So let's check. I think for another equation, I have this. Which I think is this. Y minus question mark being equal to a pound symbol times x minus one of the zeros. I'll choose a positive one. Good choice. Now you guys, I'm going to stall for a minute. Because if I pulled out my calculator, I can come up with a number of question mark, and I can come up with a number for pound symbol. So let's just talk approximations. How do I generate a question mark? Plug it into where?
You plug in one of the A value that you have into
Well, I know, I chose the first one, the 3 plus.
the positive one into f of A.
Nice. So I'm simply going to evaluate my function f at that particular value of x. Or if you want, come over here and just simply plug that number for a. Now, if you don't mind, can I pretend for a minute that I plugged 3 plus root 33 over 2 quantity squared in my calculator? I came up with a number called question mark. So, I misspoke. I come up with a number and I plug it in here and I come up with a number question mark. However, to come up with a pound symbol, what am I going to do with that 3 plus root 33 over 2 squared? Plug it into the derivative function. Or if you insist, plug it in for a in this expression right here. And I'm going to get a number. I call it pound symbol. Oh. So what does that tell me? Is that an equation of a line?
No.
See, I think it is.
Well,
I think it's an equation of a line because y and x are both being raised to the first power. It's an equation of a line. How do I check to see if it's really a tangent line?
Plug in 3
Three,
fourths.
yeah.
Beautiful. You're going to see if it does tangent line pass through that point 3, 3/4. So now you're going to plug 3 in for x and 3/4 in for the variable y and see if you get a true statement. If you do, what are you going to proclaim?
Yay, works.
Yay, that's an equation of tangent line. And if, when you plug 3 in for x and 3/4 for y, you do not get a true statement, what are you going to say?
Oh,
You don't have the equation of a tangent line. It was an extraneous solution for this equation over here. Be honest with me. I'll do whatever you like. Do you want to see me do that?
Yes.
Okay, one yes. If you guys want to see me do this, then you guys allow me up there on the screen to pull up my calculator, and I'll try to do it in a judicial fashion. Bless you. So let me scroll over here to the right so you can see my numbers on the screen. Let me get out of here. Let me clear my screen. And I'm going to try to evaluate 3 plus root 3 over 2 quantity squared. Here I go. I will open up a set of parentheses. A second set, so I can type in my numerator, which is 3 plus the square root of 33. I'll divide this by my 2 and square the result. Here's what I get. Whoops.
19.11.
I said, here's what I get. I gotta bring my calculator over.
Yeah.
So I think I get this. Do you guys mind if I cheat real quick? I don't want to keep typing. So can I hit second entry and just scroll back and change it to subtraction operations so I don't have to keep typing? I think my second solution for A, or actually my third, is going to be positive 1.9. Let's concentrate on the first one, because that's what I'm trying to do to generate that equation. To get the corresponding f value, I got an idea. Let me get back to the positive one. There it is. And I'm going to evaluate my function at that particular value of a. So I want root x over root x plus 1. Actually, do you guys think I could store this real quick? Can I just store this into a letter? I can't see my screen. How about A? That being the case, I think what I want to do is compute the square root of A. Divided by a mess, so I'll open up my set of parentheses. and help me guys, is the bottom root x plus 1?
Yes.
Then I think I've got my square root of a plus 1, and I'll close my parentheses. Here's what I get. And so I think my equation becomes this. Y minus my 0.8, excuse me, how about just a 0.8, we'll approximate, is equal to my pound symbol. Oh, but shoot, to compute pound symbol, that's nothing more than my first derivative function evaluated at that value of x, or a that came up to be 19.1. Let's evaluate it. Okay guys, here too, help me. Is this going to be 1 divided by 2 root x? Root a, whatever you want to call it. But isn't that being multiplied by, I forget, was it root x plus 1 quantity squared?
Yes.
Got it. I come with that. So is that a point, ooh, gosh, it's too small, 0.004 times x minus 19.1. So everybody, check this out. If I happen to plug in 3/4 in for y, and I plug in 3 for x, question, is that a true statement? Well, on the left-hand side, is that a negative 0.05? On the right-hand side, I have no idea what I get.
0.05.
I can't do it, you guys, I'm too tired. Is that a 0.004? Times 16.1. So 0.064. Negative, isn't it? You guys, I'm a little off. But you know what? Darn close. And I think the only reason why I'm off is I had such horrible rounding errors here. And maybe even with here. But you know what? These are approximately equal to each other. I think with my rounding error, those are pretty darn close to be the same. And so I do think that 0.3, 3/4 seems to be on that line. And so I think this is an actual equation of a tangent line. Did you guys see my reasoning? Oh shoot, there's a third one I need to check. If I actually check the third equation of a tangent line, namely this one.
So you don't want us to actually write, rounded off decimals, right? You want us to keep it in its,
Because it's not.
radical form?
I think that's best.
Best? All right.
I think this particular example is nasty numbers, but yes. I think
Yeah,
it's best.
it looks pretty scary once.
You know, if I were to check the other one, I think I need to come up with this equation. Using exactly the same logic, I think plugging in for A my 1.9, I get this. I think that gives me this. And I play exactly the same game. Now you guys, in my head, I'm trying to graph this piece, but I'm thinking that with this equation, it's not going to be satisfied when I plug 3 in for x and 3/4 for y. Did anybody get this far?
It doesn't.
It doesn't. Good. I was hoping to. Because in my head, I'm graphing this equation, and it's not looking like there's going to be 3 tangent lines passed through the point 3.
How do you graph it that fast in your head?
What's that?
How do you graph it that fast in your head?
Limits
I don't know.
and intercepts and asymptotes. It's not that bad. And look at the restricted.
It says the genius.
No, I'm not a genius. I just know a little math. You guys, is that okay if I don't finish? I take us so much time. Okay. And so to check to see if the third equation holds true, you really would have to plug 3 in for x and 3/4 in for y to see if you get a true statement, but it should be very far off. It should not satisfy.
So are you actually going to put something like this on the test?
So what's the,
Yeah.
It's a wonderful question. I haven't done it since.
so
Wait,
what's-
what? Cause this took like 4 hours to do.
Yeah.
Well, actually, if this were a test.
I got
form-
you clocked in at 35 minutes right now.
I know, if this were in an in-class test form,
Yeah.
it would have been the case that these numbers turn out a lot nicer.
Okay.
I do. I felt comfortable because I'm taking a quiz. Yes,
Alright.
I'm bright, a whole week.
I don't understand why you can't just plug in 3 for in the derivative of f(x).
Oh,
the
here's
slope of it.
here's one. If you look at the 0.3, 3/4, looks like this. It's not actually on the curve. And so I'm not really trying to find the slope of the tangent line to the curve when x is equal to 3. Actually, with my 2 colored pens in red and in blue, there's one tangent line passed through the 0.3 that's tangent to this curve. And it's tangent at that value of x. Call it A. I should call it a sub 1. And I think there's another line tangent to my curve, but also passed through the 0.3, 3/4, and is tangent to the curve at some other value of x. Call it a sub 2. It's just that a sub 1 and a sub 2 have to be approximately by 1.9 and my 19.1. Yes, sir.
Just a request, if we do end up having a question on the test where it's
Yeah.
with where the tangent, where the value we're given is not
What?
actually on the graph, can you make more clear that it's not on the graph? Because I read that and it seems like, okay, tangent line passes through 0.3, 3/4, that's part of that function.
But I never said, number one, I never said that was a point of tangency.
Yeah.
Number two, no writing. Number two, just to check to make sure that the point's not on the line, if I plug 3 in for x, I get √3 over √3 plus 1, which clearly is not 3/4.
And just looking at it now, it makes sense. But
Okay.
if we're looking at the English first time, it sounds like you'd be talking about it passes through the point on the graph, 3, 3.
Then I would have said determine the equation tangent line to the graph this function at x equals 3.
At its
It would
what?
have been very different, at x equals 3. I think that's a very different question. Is that okay? On an exam situation, you're nervous, don't be. I mean, just ask me. I mean, for me to straighten you out saying, no, you're misreading the question isn't giving anything away.
Okay.
I'm not here to see if you can test well, I'm just here to see if you can do the mathematics well. Are you okay with that?
Oh.
Okay. No.